Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem. Problem once again having been selected from the same book, that is Modern Physics by Kenneth S. Crane. As usual, we first come to its statement. Okay. An atom absorbs a photon of wavelength 375 nanometer. Nano meaning 10 to power minus 9. An atom absorbs a photon of wavelength 375 nanometer and immediately emits an other photon of wavelength 580 nanometer. What is the net energy absorbed by the atom in this process? Dear students, quite simple, quite easy, short problem. No new helping tool needs to be introduced. Okay, all helping tools which we have introduced several times in our previous problems will work. Okay, actually we have to find two energies and then their difference. Okay, their difference is asked in this problem. Okay, that is to say we will first find E1, in which we will use the wavelength 375 nanometer. Okay, we will call it as lambda 1. Okay, then we will calculate energy E2, in which we will use wavelength 580 and we will denote it by lambda 2. Okay, so lambda 1 and lambda 2 are given and we have to find out E1 and E2 and then their difference, that is delta E equal to E2 minus E1. Okay, as usual we first introduce helping tools which we have previously introduced many times. Okay, helping tool, this table has been shown many times. Okay, many times. In this table, speed of light is our relevant quantity. Moreover, Planck's constant h, which is given in two different systems. Okay, not only in joule second but also in electron volt second. Okay, moreover, combined value of h and c, that is hc equal to 1240 electron volt nanometer, or in other words million electron volt femtometer. Okay, similarly hc is given as 197 electron volt nanometer, or in terms of million electron volt femtometer. Perhaps, dear students, perhaps this is h cut c. Okay, first is hc and the second is h cut c. Anyhow, we are concerned with first value. Okay, 1240. Okay, for the time being we are not concerned with this value. Okay, okay, but yes, we are even we do not need this value 1240 electron volt nanometer or million electron volt femtometer. Okay, we can manually multiply h with c. Okay, and we can use our desired value. Okay, tool number 2, this tool has also been taken many times in our previous problems, previous videos. Okay, tool number 2, momentum of a photon, which is denoted by P, is equal to E over C, where E is photon energy and C is speed of light in vacuum. This is equivalently or alternatively equal to HF over C. This is equal to HF over C. And this is alternatively equal to H over lambda, because frequency and wavelength are inversely proportional to each other with the involvement of speed of light. Okay, that is F is equal to C over lambda, lambda is equal to C over F. Okay, this tool, that is tool number 2, momentum of a photon, is re-described in terms of energy. Okay, E is equal to HF is equal to HC over lambda, Einstein's equation for photon energy. Dear students, first alternate part of tool number 2 is about momentum of a photon, and from this we can also derive E. If we keep E on one side, then we will get the expression, the same expression. Okay, however, the same expression has been redesigned, rearranged in this form. Okay, E is equal to HF is equal to HC over lambda. Okay, this is tool number, okay, but only two tools are needed. Okay, now we come towards its solution, which is quite short, because we have to find out E1, E2 in the presence of lambda 1 and lambda 2, and then we have to take difference of these two energies. Okay, E2 minus E1. Okay, let E1 be the energy and lambda 1 equal to 375 nanometer be the wavelength of the absorbed photon. Okay, one is absorbed photon and the other is emitted photon. Okay, first we are considering absorbed photon. Okay, let E1 be the energy and lambda 1 equal to 375 nanometer be the wavelength of the absorbed photon. Okay, similarly, let E2 be the energy and lambda 2 equal to 580 nanometer be the wavelength of the emitted photon. Okay, what difference? Wavelength is different. Moreover, one is absorbed photon and the other is emitted photon. Okay, hence we have used tool which we have shown above. Okay, E1 is equal to HC over lambda 1 is equal to 1240 electron volt nanometer divided by 375 nanometer. Okay, here dear students, we have not taken value of H separately and value of C, that is 2.998 into 10 to power 8 meter per second. Okay, we have taken combined result which is also given in the same table. Okay, over lambda 1 is given 375, and after simplifying, here nanometer will be cancelled out with nanometer and we will be left only with electron volt, and this is 3.307 electron volt. Okay, hence energy E1 has become equal to 3.307 electron volt, or simply we can also write it as equal to 3.31. Okay, it is just our discretion. Okay, similarly, E2 is equal to HC over lambda 2. Then again, in place of HC we have taken its value which is given as a combined form. Okay, 1240 electron volt into nanometer divided by 580 nanometer. Nanometer will be cancelled out with nanometer and we will be left with 2.138 electron volt. Okay, hence E1 has become equal to 3.307 electron volt, while E2 has become equal to 2.138 electron volt. Moreover, delta E equal to E1 minus E2. Put the value of E1 and E2. So 3.307 electron volt minus 2.138 electron volt. Okay, both quantities have the same unit, that is electron volt. So we can simply say this step as that we take electron volt common outside the bracket, then within the bracket we will be left 3.307 minus 2.187, and this will become equal to 1.169. okay, so delta E, our desired change in energy, has become equal to 1.169 electron volt, or alternatively we can also write it as 1.17 electron volt. However, it is just a matter of discussion, and this is the end of our problem, our video. Till next video,